joining today's webinar presentation in regards to the EC Titanium product beyond EC efficiency and performance. I am Mark Dimitro, your host today and product manager, Variable Speed Motors. This webinar, as Brad indicated, will be recorded and available for download in a PDF form at a later date. So you can have my contact information there if you have any follow-up questions or would like to contact and reach me personally. So what will we be discussing here today? We're going to be talking about the EC Titanium. This will be about a 40 to 45 minute presentation, and then we'll open it up for a Q&A session. If we don't get to your Q&A, I'd be happy to respond to you via email as well. So fundamentally, the EC Titanium is a IE5 product that we achieve using a synchronous reluctance rotor with embedded ferrite magnets, which you see here in this picture. So this is a nice illustration of the rotor design and technology that is what the product at its core is about. So it has a synchronous reluctance rotor, which is characterized by these horseshoe or half moon circle cutouts in the rotor, but a typical synchronous reluctance motor has blank spaces between those. And then we embed ferrite magnet material in between there to give you an interior permanent magnet, ferrite assisted synchronous reluctance rotor. And that we're calling that the EC Titanium, and I'll discuss it in regards to the IE5 and what the market demands and what really drove the emergence and development of this technology. We'll do a brief update on the product and what's new and what will be coming soon for it and its availability. Then we'll do a little deeper dive into the actual efficiencies and do a comparison and take a look at how those efficiencies are not only maintained at full load and full speed, but at partial load and partial speed points, which most pump fans and compressors operate at those points more than full load and full speed. And then we're going to get a little bit more into how you set up the product, what available resources are online to help you with the configuration and sizing, and also our PC software, mobile tools, and something new that you probably haven't seen in previous presentations if you've joined me, is we're going to be talking about the ABB ability, the digital powertrain, which is basically a conditioning, monitoring, predictive, and preventative maintenance tool that comes standard with the product and is included in all Bluetooth-enabled drive units. So who are we? Well, we are part of ABB. ABB is a leading global technology company that has over 110,000 employees across the world globally to support your products. So if you do international work and ship your equipment overseas, we are fully capable of supporting you internationally. Over 130 years of experience in over 100 countries. We are part of the Baldor Reliance NEMA Motor Group, which is the #1 global manufacturer for NEMA motors, over 3,700 employees worldwide, 7 manufacturing locations, and we heavily invest in research and development and engineering, which obviously helps develop products and new technologies like we're discussing here today. You can see here from the map that we are primarily with 6 manufacturing locations, a North America manufacturing company, Baldor Reliance North America. This product is actually manufactured right here in Fort Smith, Arkansas, and comes down the standard high volume production facility lines that are standard NEMA 140, 180, and 210 frame Baldor Reliance motors are manufactured on today. So the same quality, manufacturing standards, etc., that you're used to at Baldor Motors. This product is made on those same lines, nothing special in that regards. So who is Baldor? Well, our mission is to be the best, but only as determined by you, our customer, of being a marketer, a designer, a manufacturer, and a service provider of industrial electric motors, generators, and mechanical power transmission products, while at the same time taking care of you, our customer, and doing it safely. So why are we talking here today about IE5 efficiencies and energy efficiency? There's been a number of initiatives over the years to improve motor efficiencies, but it continues to accelerate because when you look at the global market demands for electricity, they are going to double by 2040 as the projected estimates. And that's equivalent to adding the size of an electrical market of China, which is, 1.4 billion people. If you want to put that in context, I think Texas has 25 million people. So you can imagine adding in the market size of China for electricity by 2040. That's why it's critical to continue to drive energy efficiency of systems and drive down consumption of pump, fan, and compressor systems and electricity. And that's because, motors consume about 1/3 of the world's electricity. So that's a big sizable chunk of where this electrical demand is being consumed. So this product is directly there to help overall system efficiencies in your designs and meet new emerging system efficiency regulations, which primarily were originally more on the components, so driving up the efficiency of just the motor itself. But new legislation that's coming on, and it's kind of in a staged approach. So if it's in the fan market or the HVAC market, it's not across all units, but it might be starting in roof-mounted air handling units. And in the pump market, it's not all pumps, but we're seeing it emerge in, let's say, pool pumps or something. But it's really driving total system efficiency. So not just the individual component, but the overall efficiency of that air handling unit, let's say. And not only at the full load and full speed points, but at partial load and partial speed points. So this design is really geared around helping you achieve those efficiencies at those multiple points of operation that the new legislation is keying in on. So what is the product here today? You can see it here. It's in 3 configurations. There's a motor only that you see in the center picture, and that can be controlled using a permanent magnet drive. I'll talk a little bit about the nuances of that and what you need as far as a standalone drive to run the motor. All motors do need a drive to run. They will not run across the line. Or we provide an integrated unit, which you see as either an axial or rear mount drive or as a top mount. So depending on if you want a little longer product or a more compact with a top mount drive, we have both of those. So it's an ultra efficient, innovative magnet technology product. It's sustainable in that we don't use rare earth magnet materials, which I touched on that before. It's ferrite magnet material, and reliable. And all units that have drives mounted on them are Bluetooth capable, and you can wirelessly connect. So we'll be going through a little bit more in that into the digital section and the software setup. So again, it's IE5 efficiency. We want to maintain that efficiency at full load, but also at partial load and partial speed points. We'll get into that more in the efficiency section. Minimize your environmental impact. Obviously, the higher efficiency, less losses, less energy consumption. But also, we don't use rare earth magnet material, and especially even now with the availability of product internationally, it's important to have readily available materials that are not susceptible to commodity fluctuations and limited supply. So rare earth magnet materials are traditionally used in permanent magnet control because they're very dense, they have very strong magnetic fields, and it doesn't take a lot of magnets to produce it, but they're hard to source. They only come out of a few places in the world. So we use ferrite magnets, and they're readily available and not volatile in the commodity world. So together as one, cut the cord, we integrate the motor and drive together, and that makes for a plug-and-play package, meaning that we do all the programming at the factory for you. When you take it out of the box, it's basically ready to run with a start-stop command and a speed reference. They're fully programmed and set up. There's no tuning you have to do, etc. The only reason you would get into and do programming changes if you wanted to do the control from somewhere else, maybe adjust the XL and decel ramps or etc. But you can literally take it out of the box and it's ready to run with just a simple speed reference and a start stop. Reliable and low noise because of the permanent magnet control. It has extremely low starting current and less cogging than traditional designs, which reduces mechanical stress and produces a quiet operating product. And as a testament to that, if anyone's run a motor across a drive before, it can be fairly annoying. And I've run tests in my office and had it running all day, and it hasn't gotten on my nerves. So that'll give you a little indication of how quiet it is. Power dense, because of the high efficiency, that leads to less losses and a cooler running motor. So you'll see it here in a little bit, but we can provide in many of the horsepower sizes one frame size down than a traditional NEMA motor. And so that gives you if you want a smaller, lighter weight motor that maybe help with your structural design or somewhere where you're trying to fit it into a compact area. Now you pay a little cost in efficiency and it does run a little warmer, but still within a Class B rise and still within the IE5 efficiencies, which I'll show you here in a minute. So again, we already touched on this. Efficiency legislation is impacting air handling and pumping industries, and it's driving you, the OEM, to look at IE5 technologies, and that's why we developed this product that we'll be talking about today. ABB is an expert in drives, which is part of the integrated drive motor package, in motors and mechanical gearing, and helping you effectively convert that electrical to mechanical power. And we have years of experience with motor control technology that was used to develop the algorithms to properly control this interior permanent magnet motor. One of the key things is a lot of other types of units out there might come prepackaged with the fan or the pump. We're not in the business of supplying those. We're a motor drive manufacturing and supplier, so that's what we do. It's drop-in replacements for standard NEMA induction mounts. There's nothing fancy about it. Standard NEMA 140, 56 frame mount, C-faces, etc. And then also we have extensive experience in the Internet of Things, ABB Ability, and helping you collect data and diagnostic information about the product, and we'll be talking about that in that section. So let's just do a little product overview and update for you. These are the three configurations that are available. It's available as a motor only, up to 20 horsepower. Their current release is a NEMA 140, 180, and a 210 frame, and they are all 230, 460 three-phase input motors. Now, again, they have to have a drive to operate. They won't operate across the line. And then when you're looking at it from an integrated motor and drive standpoint, you can get it in a top mount unit up to 10 horse, or in the axial mount up to 7.5 horse, and that's just a frame limitation. So on the axial mount, we go up to a 180 frame with a rear mount drive on it, which gets us to 7.5. In the top mount, we can go up to a 210 frame, and that'll get us up to 10 horsepower in the top mount. But you can also use these as a phase converter because there is an integrated drive on there. If you're putting these into single phase applications in 115 or 230 volt, you could use this instead of a single phase motor as a phase converter and operate this across single phase power. And then you go three phase output to the motor itself. We do all that wiring internally for you. So we go up to 1 horsepower 115 volt, or 2 horse single phase 230 volt, or 3 phase up to 5 horsepower 230 volt. So this is an exploded view of the product. You can see from a typical stator and rotor assembly standpoint, it's just a rolled steel band motor like we produce today in Fort Smith, Arkansas, and it comes down those same production lines. And what's unique is the rotor technology, which you see here in the middle, and I had that exploded view of it previously, with the synchronous reluctance rotor and the embedded ferrite magnets to give you the IE5 efficiency. Because these are all run on a drive, you will have instances, depending on the grounding system, of common mode noise and voltages on the shaft, which can lead to bearing damages. So we want to eliminate that concern and make sure you don't have to worry about it. So all of the product, including the motor only that is sold for a separate drive, comes with an internal shaft grounding brush. Now we can do options for like an Aegis ring or ceramic bearings, but the stock product has the ground brush in it. It uses the same Polyrex EM grease that we use on our standard motors today. It's a totally sealed bearing. There is no regreasing required on this product. It is a Class F insulation system. However, because of the low losses and high power factor and extremely cool running product, it's only a Class B rise. So I've had the question, is it a Class H insulation? Well, no, but you don't need it. What you really want is to keep the temperature rise of the motor down. So you don't need Class H if you have a Class B rise motor. And so that's a very cool running motor with a Class B rise. And that leads to long insulation system life, less thermal breakdown of grease, allows us to use the totally sealed bearing and give you a long running product. We are using a Mylar nameplate. I'm not going to go into that in a whole lot of detail because I have an expanded section on it, but there's a specific reason we did that because there's a lot more data on the nameplate than a standard metal laser etch type nameplate might have. And all of the product is an IP54 rated and passed in test, which I have a slide on and I'll go into. So the standard product is IP54. So here's a little bit more of an exploded view of the rotor technology. We're calling it the EC Titanium because in the market, there are a lot of specifications that literally call out an EC motor instead of calling out IE5 efficiency. They just say because EC is kind of taken on the name and the connotation as an IE5 efficient product. It technically actually stands for an electrically commutated motor, which is a surface mount permanent magnet DC design. This is actually an AC induction motor with the ferrite assisted synchronous reluctance rotor. But that's why we're using EC in the name, because that's just the industry recognition. Again, we already talked about this, IE5 efficient, excellent power density, accurate speed control. Well, obviously it's a synchronous motor, so it's going to run at synchronous speed with no slip. So it's always going to give you good speed control. Low bearing and winding temperature and high power factor, and maintains efficiency at low speeds, which I'll be showing you that in a future slide. And tailored design performance, meaning that, we have standard stock ratings, but we have pre-configured engineered options. So if you want to do a C-face mount or a pump mount or any type of mechanical mount, that's very easy to do with this product. This is just kind of a visual. I don't need to spend a lot of time on it, but this is why you want a shaft grounding system in a motor. This kind of noise you see here on the right is what we call common mode voltage. That causes electrical discharges and bearing damage, and you put in a shaft grounding brush here on the left, and that just basically eliminates the noise and the concerns you might have with common mode voltages. This is what I actually talked about from a configured offering. Our standard stock unit is 1800 RPM. However, we have pre-engineered the windings for 3600, 1200, and 900 RPM. We can do different face mountings. We do have new enclosure types coming out. So the standard product with Bluetooth has plastic covers, and we have an option to use metal covers if you have a plenum use application. And we have different accessories and kits that I'll be talking about. And it's a fully serviceable product, meaning that the drive can be replaced separately from the motor or vice versa. So if something happens to the motor or something happens to the drive, you don't have to replace everything. You can just service that individual component. Here's the different ratings, and I know this is kind of a chart to look at everything, but it does give you a representative sample of the efficiency range. So we're starting in here at a 1 horsepower at 89.3% and climbing all the way up to 95.9%. All of these products are fully UL listed as the entire assembly, and these are the UL listed efficiencies that are recognized. So these are published UL efficiency values for the product. And all of these can be run above base speed. So for example, a traditional electrically commutated design, and this is just a technology limitation, it's not just me making a comparison. DC machines aren't going to run above base speed, so they're limited to up to base speed or below. On the advantage of this being an induction motor is we can run into the constant horsepower range. So if you have an 1800 RPM motor up to a 180 frame, we can go to 4000 RPM, and then a 210 frame up to 3000 RPM. So here's our ratings again, starting at 89 all the way up to 95% efficiency. Now this is for the motor only. And you're going to see about, in our testing, about a 1.5 to 1.8% additional losses in the drive. So when you add the drive in, what you need to take out another 1.8% on the front end of the drive and losses there. But in a lot of cases, because this is at IE5 plus efficiency, even with the losses of the drive, we're above the IE5 efficiency level. We are going to be adding in a 3 horsepower 230 volt rating, which you see here, probably in the fourth quarter. So I wanted to let you know that that is something up and coming in the future. And then this is the specification. On the integrated units, you have the full voltage tolerance associated with the standard drive. From a thermal standpoint, when you have an integrated drive, it's an electronic component. It's only going to be able to operate down. I mean, think about your cell phone. You take it out into minus 10 degrees Celsius weather, it's not going to operate. Well, a drive is no different. It has a low temperature range and a high temperature range limit. So it's minus 10 to 40 degrees C, and then you derate per degree C up to 50 degrees C maximum. And it is fully IP54 as standard. Various different base carrier frequencies, etc. I don't want to spend a lot of time on this. This is just for reference if you go and get the presentation later. IP54, I just wanted to touch on this. This is what an IP54 test looks like. So you have an independent certification company that does the dust test. You have to pull a vacuum, which is what this hose is, on the interior of the motor, and then you can't get any dust inside the product. And then the water test is basically water hose pressure, like a sprinkler system basically, and then you have to spray it at various angles as you rotate the motor. And you put a water sensitive dye inside, and then when you open it up, none of that dye can have turned to a blue color. It's a white to begin with, so that it's very easy visually to see if any water gets in. So it is a fully IP54 tested product. From a future standpoint, we are going to be enhancing the product offering from the initial stock release. Again, I already touched on this. We're going to have the plenum use with metal covers that will replace the top cover with a die-cast aluminum cover, and the fan cover also with aluminum for plenum use. However, Bluetooth doesn't operate through metal very well, so for those units, they will be non-Bluetooth units. And if you need Bluetooth, there's a little jump stick that you could add to it to get the Bluetooth back, which I'll touch on. And then we're going to be coming back in, and we'll be stocking C-face configurations as well. You can see the engineering drawings are already completed. We just launched initial stock ratings as foot-mounted units to begin with. So that will be coming later this year as well, probably by the first of the fourth quarter. All right, so let's talk a little bit about efficiency. So this is the IE chart for efficiency and how it really correlates to the NEMA standard. IE3 is like a NEMA premium energy efficient motor. IE4 is a super premium. And then the industry is kind of starting to use this term because it just hasn't existed before for IE5. It's a ultra super premium energy efficient motor. Now, what the IE bands are, it's really an IEC standard. And all it really means is that for each band of efficiency, so like going from IE3 to IE4, is there has to be 10% less losses in the motor. And less losses means higher efficiency. So what we're talking about here today is the IE5 efficiency band, which is this black line here. Now that's for the motor only, but none of these motors that are in existence today, there are no IE5 motors that run across the line. So IEC came back and came up with a standard, which is this dotted yellow line, which is the IE5 standard for the motor with a drive. And you can see all of our products are at or above. So in this case, this black line is the true IE5 standard. If you look at a 5 horsepower, it's 93.7%. So it's 0.7% higher than the IE5 standard. So even when you add a drive, in a lot of cases, it's still above IE5 standards. Now, again, remember I talked about power density. So you can get a 5 horsepower in a 180 frame, or you can get a 5 horsepower in a 140 frame. So you pay a little bit in efficiency, 0.7%, but it's still above IE5. So it's just a matter of, do you want a smaller, lighter weight motor, a little less efficient, might run a little warmer, or a standard NEMA frame. So we give you those options at 3 horsepower, at 5 horsepower, and at 7.5 horsepower. But again, that's at full load and full speed, and that's not typically where a pump, fan, or compressor runs. Most of them run on that bell-shaped curve that you see in the gray lines there. So they're running the majority of their time at 80, 60% speed and at partial load conditions, because it's the cube rule of speed and load. So, if you're at 80% speed, you're only at 50% load. So what you really have to look at is, well, what is my motor efficiency if I'm operating at those reduced speed and reduced load points? And then do your calculations and say, how much energy am I actually saving for my end customer when operating at those points? Because if I did the calculation up here at full load and full speed, that nominal percentage difference doesn't really give you a whole lot in your payback analysis. But the key to this technology is that as I come down in the speed load point, we are maintaining our efficiency much higher than a energy efficient motor, induction motor, or traditional EC motor, which is this dash line. And in our testing in the lab, it's as much as a 16% differential between induction and can be up to 10% higher than a standard EC motor at partial load speed points. So how does that really translate to energy savings? So we basically took that lab test data. So that wasn't just a made-up curve. That was actual lab test data that was just put into a curve. And then we ran those calculations over that bell-shaped operational curve at those load points and the different efficiencies. And then when you do your payback, you can actually see like an induction motor would cost over $725 annually to run that 3 horsepower motor. And we're saying, since we're maintaining our efficiencies higher at those partial load and speed points, it's only $445. So that can, be up to a 20 to 40% energy savings over traditional designs, and really help as far as the payback analysis when selling new equipment to customers that are looking for energy savings. This is just kind of a new concept that I want to discuss. I am going to be coming back later this year and doing more just of a technology webinar on just this concept, which is what we call efficiency islands. And it's really about matching the system curve for the pump, fan, or compressor at in and around a efficiency island operation point. So again, remember I said you can run above base speed. So if I want to run at 2250, let's say I got 5 brake horsepower at 2250 RPM, instead of taking a 3600 RPM motor and slowing it down, we're saying that take that 1800, overspeed it, even if you have to oversize the motor slightly to get the torque you need out here, you're going to be much better off because you're going to be operating in this constant efficiency island above base speed. So tune in later for that technology webinar where I'll go in more into depth about that. But basically it's saying let's maximize our operating range above base speed so we don't have to operate as much below base speed where the efficiency starts to drop off. This is just a thermal image. We don't need to spend a lot of time on this. Just the motor thermals. You can see it's much cooler running, about 20% less heat generated. That just gives you longer life of electrical components within the product. This is an equivalence test, meaning we ran it with the same drive on the back end of the motor. This is an induction motor, and this is the EC Titanium. Easy setup and connections. So again, I already touched on this. We do all the programming under the hood and wiring, so we make all your motor connections here. All you have to do is bring a three-phase power, a speed reference, and a start-stop switch, and you're ready to run. And so it's plug and play, and we do all the pre-programming for you associated with it. Also, I said I was going to get into the nameplate a little bit. Every nameplate, being it's a Mylar nameplate, one of the reasons is they're all QR coded. So you scan that QR code, it goes to our web page. You can get all the specifications, you can get the drawings. If it's in a hard to read area and you can just scan the QR code, you can get all the nameplate data, model and serial number, etc. And smart guides, etc. So that's why it's QR coded. And then the nameplate itself has a lot more information on it than a standard induction design. Again, I said if you're going to run the motor only on another drive, it has to be a permanent magnet controller, but then it also has to have the accessibility to put in some specific parameters. So in our experience, a standard ID run is supposed to calculate these values. It doesn't really do it well enough. And so we give you the information. We would recommend you manually set these up in a standalone drive. And those are like stator resistance, two values of inductance of the magnetic fields, LD and LQ, back EMF voltage, and rated amps and frequency. So you have to put all these values in. That's really what an ID run would normally calculate anyway, and we just give them to you and suggest you manually put them in. And that's why we have the more detailed nameplate on them. This is the drive module under the hood. Just nothing really exciting here. It's a basic drive controller. It's got up to 4 digital inputs or 2 analog inputs. So you can have 2 digital in and 2 analog in. They're dual function digital analog inputs. An analog out or digital out. The standard controller has serial Modbus with an RJ45 port or twisted pair plus minus. And we'll be adding BACnet in a future release as well. And then there's a relay output on it. And again, these modules are fully field retrofittable, have a built-in stirring fan on them. It's not really for cooling, it's just to get even air distribution inside the enclosure with an EMC filter. Now, I said that you have to manually set these up with the parameters. However, I started this presentation by saying ABB is a drives company and knows our motors and how to control them. So there is a release of the firmware for the ACH 480 and 580 that will do the ID run. And you don't have to set up anything. So if you're going to be running it on an ABB drive, the ID run will run the motor just fine, and you don't have to manually put in these parameters. Now, some of the other advantages you get with standalone drives is additional optimized speed and efficiency ranges. You can do more integral harmonic mitigation because there's ultra low harmonic versions of the product. More extensive range of networks. So again, I said we had serial Modbus and BACnet, but you can get Ethernet, Profibus, and etc. with standalone drive and more extensive pump and fan features. So our basic controller comes with this, has basically 40 parameters on it. So let's quickly show you. If you go to Baldor.com and you go to our products and variable speed motors, you will find the EC Titanium, the full-blown instruction manual there. There's also basically I said it's ready to run out of the box. So you don't need a 90-page instruction manual to set this up. So we also have just a quick 4-page quick start guide that gives you the basic information for starting it up, etc. If you click on the online catalog, you'll go to the product page. You go to the product page, you can get all the specification information. And one of the things that everybody likes to have when you're integrating it into new equipment is the CAD drawings or the 3D step files. So those are all out there and available and downloadable from the product page site. All right, so we've got a few minutes here left, so let's get back into software and programming. So from an interface standpoint, up here from a remote standpoint, we can go Bluetooth up to the cloud base and ABB ability, which is for your data acquisition, or we can go Bluetooth to we're calling EC Mobile Tools, or your PC, and for programming and setup and operation of the motor, or again from that control module, all your hardwired control. So from a kit standpoint, we have a basic keypad for setup and programming or operation of the unit. Being a RS480, a standard serial interface, you can also daisy chain the keypads together, or have one keypad and then a splitter going to multiple drives, and then you can just do node assignments. So let's say you had a fan array and you had 12 fans on that. You could connect them all serially together with the splitter and have one keypad, and then just select which node you want and look at the drive. This is a copycat keypad, a copycat stick. Simple upload download stores one set of drive parameters. So again, if you're setting up multiple units, program one unit, upload it to the copy stick, take it over to the next unit, and just download it to that. From a programming standpoint, if you do a hardwired connection to your PC, that's what this cable is. It's a isolated cable to make sure you get good connection. Drives put out a lot of noise, so if you don't use an isolated serial to USB cable, chances are you might not make a good communication connection. Again, this is your keypad, start, stop, speed control, and the navigate key gets into your programming mode. You can daisy chain them up to 63 drops. From a programming standpoint, I just want to show when you get into the keypad, this is what it looks like. And you've got a short, long, and advanced parameter group. Short group is for just setting up accel, decel ramps, etc. Advanced is for your motor parameters, and the long is all the parameters. Now, I would tell you, when I set up a drive, if I get in there, I just go to the long list. There's only 40 parameters in the entire drive. So it's not like you're wading through 300 parameters that need to be divided into different groups. So that's a pretty easy drive to set up and program from that standpoint. Here are some other programming tools, though, if you don't want to use the little handheld keypad. By the end of this month, we will have available and downloadable off our website the PC tool. So again, you can take that hardwired cable or Bluetooth and connect with your PC or tablet and set up and program the drive, or we'll also have it downloadable from the App Store or Google Play, a mobile tool for setup and programming of it. So here's what the PC tool looks like. It's a pretty standard PC tool from a setup standpoint. Upload, download parameters, save them to local, etc., and back up your drive. You can program it offline and then connect to a drive and then download the parameters that you set up remotely. It does do a comparison between what's the factory defaults on the right and what's in blue text on the left, so you can see what's been changed. Here you can see if you want to connect over Bluetooth, it's just simply go in, select Bluetooth, find the drive, and hit connect. It's going to ask for a pairing code, which is in the manual, but it's simply 6 zeros. So it's nothing fancy, just 6 zeros to pair the drive with Bluetooth. There's also a chart recorder for diagnostics and setup, a start-stop control and speed reference and monitoring tool. So if you want to run it there right off the PC tool, you can do that as well. And again, these are also all upgradable from a drive firmware standpoint. So again, remember I mentioned we're going to release BACnet That doesn't mean you're going to have to get a new drive module. You can simply get the new firmware, download it, and upgrade the drive, and it'll be backward compatible. So not a problem. So here's your mobile tool that we'll be releasing. So again, connect to the drive. You can do upload and download of parameters. It searches for the drive here, found it, connected. You go into your parameter editor. It looks a lot like the PC tools. The different menus, the blue text for changes from factory defaults. Go in, change that value, download it to the drive, or save it locally to your phone. Now it saves it locally to your phone. It doesn't upload it to the cloud from a data security standpoint. Again, there's also a start-stop control built into it, so you can run it from your mobile tool as well. Do direction control and see, motor power and current, and some diagnostic parameters. All right. So now let's get a little bit in as closing minutes here into ABB Ability and the digital powertrain. And what is that? Well, ABB Ability Digital Powertrain is a suite of digital monitoring technology that is designed around improving overall performance and reliability and efficiency of components within a powertrain. So there are various ABB Ability sensors on the market, and they look at values like temperature and vibration and things like that, and then they're used for predictive and preventative maintenance. There's a pump sensor, there's a bearing sensor that can be mounted in the system that's looking at, vibration and etc. There's a motor sensor, and then the EC Titanium with the integrated drive all comes standard on Bluetooth units with ABB Ability built into it. So you get that as standard. So I want to take a minute to kind of explain, well, what is that and what does it give for you? All right. So here's what it looks like. It's basically a sensor that's embedded within the drive, and you can communicate to it. Either you can walk up with what's called the ABB Ability app on your mobile phone, and you basically look for the drive and connect to it, or we can do it with a hub here and pull the data out remotely. So here again is what it looks like. So the parameters that we're monitoring in the drive are things like temperature, both the drive module and the control board, DC bus voltage. We're looking at speed, frequency, voltage, some status of some I/O, and then motor power and torque that could be used to do efficiency calculations for your actual energy use over time. Again, you plug in, this is the ABB Ability app. Basically, every one of these is, there's no subscription, comes standard with the drive, it's pre-provisioned, and basically you go in and you just click commission a new asset. It'll find the sensor on the drive. You just click the plus symbol, and it'll commission that as a new asset, and you're ready to run. And then you can look at health parameters on the drive. When you actually scan this drive and then connect to it, it takes it up to what's called the ABB Ability web portal. You can look at the data on your phone, or you can go to a web portal that looks like this, and then you can look at and trend the data out over time for just the drive itself. So this is just the EC Titanium drive. Obviously it's a predictive and preventative maintenance tool designed around reducing maintenance cost, because unexpected downtime is far more expensive than doing preventative maintenance. So the idea here is to get a window into equipment so that you can do preventative maintenance ahead of any type of catastrophic failure. So you can look at the web portal and look at the drive parameters specifically that it's monitoring, but they're all digitally time-stamped. So you can also go in and look at them on what's called the digital powertrain. So let's say you had a bearing sensor that was on a fan system. You might be looking at vibration or temperature of the bearing, and then you might want to correlate it against speed or power consumption of the drive. And so that's the digital powertrain takes multiple sensors and mirrors them together, and so you can look at multiple sensors in a system versus just the drive sensor itself. So again, it's a predictive and preventative maintenance tool. It all comes standard and free with the product. There's no subscription or required. You just have to sign up on the web portal and also commission the drive. The services organization does have remote assistance and conditioning monitoring services as kind of an add-on above that, though. But if you're just doing them all in-house, that comes standard with the product. So if you want to share this, we will be making this presentation available electronically. If you want to share this within your organization or your reps, there's also just a little minute 40 overview of the product on YouTube that if you want to go and look at or point people to get a little bit of a teaser into the product. But in summary, they're really just this product is designed around meeting IE5 efficiency levels. We don't want to use rare earth magnet materials so that it's a readily available product. And we use standard motor architecture. So one of the key things too on this that I really didn't touch on was it's a drop-in replacement for a standard NEMA motor mount. There's nothing special or fancy about it. So you can replace standard induction motor with this, and it's just a bolt-in replacement. And it's available as a motor only or with an integrated drive. And with that, that's what I had for you today. Thank you for joining. And we're going to open it up here in our 12 minutes left for questions.
Great. Thanks, Mark. We did have several questions come in, so we'll start knocking those out right away. The first one is around the future release of products, so the 2 and 3 horsepower models. Is there a time frame for those, or just later in 2020?
Yeah, I anticipate it'll be beginning in the first quarter. So, but yeah, later in 2020, but early first quarter, fourth quarter.
Okay. And then what's the full voltage range on the motors? Is it different per horsepower? Or
for the motor only, was it the question specific to the motor only, or the voltage
for the whole platform?
Okay, well, I mean, on the motor only, it's 230, 460, and keep in mind on the motor only, every one of these has to run on a drive. So the drive itself is going to be the mitigator on voltage tolerance, and our drives have the same voltage tolerance as most drives out there. So, for example, on a 460 volt drive, it might be 380 plus or minus 10% up to 480 volts. Now, bear in mind, if you're going to be running down at lower voltage, the drive will power up, it'll supply the motor, but it's going to draw more current. Less voltage means more current. So, keep in mind, even though the drive has a wide voltage tolerance to it, we have to look at and say, well, how much current is it going to be drawing if I'm only giving it 400 volts? Typically, the drives are oversized to the motor amps, so normally it's not an issue, but it's something to keep in mind and just look at. And it's just a straight calculation, 400 over 460 times the current.
Okay, great. The next question is around ambient operating temperatures. Is there limits between the motor only and the IMD version different, or are they all the same?
They are different, actually. The motor itself, I didn't touch on this, actually carries a 1.5 service factor. Because it's such a low temperature product, you can actually drive it up into 1.5 service factor above its rating, which means that typically on the motor only, if you're going to be running it in very high ambience, you're just running it into the service factor range. So yes, we can go much wider in the high temperature range and into the low temperature range, and pretty much the same that you can do on any Valdo Reliance motor today. So if you're going to go really high temperature, we might need special grease. Same, mostly in the motor it becomes special grease, high temperature grease or low temperature grease.
Great.
And then the limitations on the integrated unit is just with the drive unit itself.
Okay. Well, we'll let's stick with service factor for 1 second. You were mentioning that you could overspeed an 1800 RPM motor, but the service factor that you showed was 1.0. So when you overspeed that motor, would you need to use a higher horsepower to counteract with the service factor?
Potentially. I mean, you need to look at the system and what brake horsepower you actually need at your operating speed point. Because you're running it in the constant horsepower range, and your torque will drop off. So you have to look at and say, if I'm going to be running it at 2250 RPM, what's my brake horsepower and how much torque do I actually need at 2250? And to your point, let's say it was 5 horsepower, I might need to use a 7.5 horsepower motor and drive to get the right torque out. So yeah.
Okay. Next question is, are you able to download startup reports for customers if you program the drive?
Well, if you're using the PC tool, you can save the configuration local and then do a printout of all the parameter setups. I'm not sure that's exactly the question, but yes, you can print those out and put them into Excel or print them to a PDF as far as the setup parameters inside the drive itself.
Okay.
Using
Great.
the PC tool.
Okay. And the next question is, are high thrust bearings or custom bearing configurations available?
Yeah, again, any of our standard motor mechanical options that you would see in Fort Smith would be available with this product too. So, short of, for example, you're not going to mount a brake on the integrated unit because the drive's there, right? So, there's some mechanical limitations, but beyond that, thrust bearings, ceramic bearings, etc., not a problem.
And then what about IEEE 841 standards, Division 2 standards? Are those being looked at or potential future?
They don't exist currently for the product. Specifically for the motor only, we can take a look at them. Again, this question came up yesterday, and my answer, and I'll stick to it, is I don't know enough at this point to answer that properly, so I'm going to take that, and that will be an update that I'll provide as an output of this webinar.
Great. And then the last question that I see is, does the drive have to auto-tune at every start?
It does not. Now, there's an alignment of the magnetic field, so it does a quick DC pulse, and that basically aligns the rotor to the stator magnetic field, but that's not an actual tune. So there is no auto tune that's required. That's why you have all the manual setup parameters in the drive.
Okay. Oh, we have questions coming in. This is great. The next question is around bearing and winding RTDs. 1, are they available? And 2, are they even required?
Well, yeah, we can do thermocouples. I imagine we could do an RTD as well. I'm not sure they're really required in that you have a drive there that is limiting current to the motor, which is the thermal issue typically with the motor when it draws excessive current. So you have a drive there that is monitoring current output to the motor and protecting it. So you could argue whether that's even really required or not. Yes. However, I know we've done thermocouples, and we could probably do RTDs.
Okay. Next question is, other motor technologies ignore harmonic distortions. Where do these stand for distorting harmonics and impedances?
Well, they put out traditional harmonics just like any PWM drive. So the type of harmonics you would see with this product be very similar to, an ABB ACS 380 drive or something like that. I mean, it's a standard PWM controller. And what you're probably asking too is like traditional EC motors being DC put out harmonics in non-traditional points, and so they're very difficult to actually filter. With this product being a standard PWM controller, it has harmonics that a standard harmonic filter will easily mitigate, or you could just do simply like some input impedance ahead of the drive with a reactor, just like you do with most PWM drives. But
Okay.
it's not built into the product, so any harmonic mitigation would be external.
Okay. You talked about the upper ambient limitations. Just to maybe you may have covered this, but are they good to -40 C?
You can only, yeah, so the limitation on the integrated units is only down to -10 C. So if you want to go -40, our only option at this point would be the motor only, and then low temperature grease.
Okay, and then any concerns with windmilling or power generating?
No, yeah, we've done testing on that, and that DC pulse I talked about that aligns the magnetic fields catches any windmilling, and it also has a catch a rotating load built into the software.
Okay.
And we've tested all that. So.
Well, great. Thanks, Mark. That's
Welcome.
all the questions that I have seen come in. If there's any last minute questions, otherwise I'm gonna do a wrap up and appreciate your time. Appreciate everybody's time today for jumping on the webinar. Again, one last plug of please provide your feedback from today's session in a quick survey at the very end, and we hope that you have a wonderful rest of your day. Thanks.